I'm sure more people will join as we go along. So welcome to this workshop on cyber infrastructure. This is dealing with the administrative data, which are typically big data. This is a cyber infrastructure workshop, which is a part of our NSF project on cyber infrastructure. And I have my colleagues here, Dr. Giri Narasimhan, who is from computer science, Dr. Shaoming Cheng, who is my colleague in public policy and administration, and Farzana Yusuf, who is a PhD student of Dr. Narasimhan in the computer science. Let me first go around very quickly, since we are a few of us, as for introduction, as to where you are. And one of the things I learned from participating in nonprofits is an icebreaker. So an icebreaker, like, what's your favorite fruit? So if you could tell us where you are and what your favorite fruit is. So let's go around with Christina.
Sure. My name is Christina Stanicom. I'm a lecturer in the School of Public Policy and Urban Affairs at Northeastern University in Boston. I'm happy to join NASPAA. It's my first time I attend this conference. I'm looking forward to engage with everyone and learn more about cyber infrastructure and R, since it's very trending right now. And I have what's my favorite truth is that there is only one truth. Not too many. So like today, you know, we have various. Yep. Thank you.
Thank you. Betty?
Hi, everyone. My name is Betty Vu, and I am from Cal State University, Dominguez Hills, and I've been here for about 8 years. And I'm just interested in learning more about R. And my favorite fruit, I would say, is mangoes, especially from Asia. Not here in Americas. They're not that great.
Michael?
Hi, I'm Dr. Michael Overton at the University of Idaho in Moscow, Idaho. In case you don't know where it is, it's about 10 miles away from Washington State University, which is much more famous, right across the border. I'm here because I'm very interested in researching data literacy and data science in public administration. And so I kind of signed up for this on a whim, and I'm excited to see what happens. My favorite fruit is a banana. So there we go.
Melissa?
Hi, everyone. My name is Melissa McShay. I'm an assistant professor at John Jay College of Criminal Justice in New York City. I am really excited to be part of this workshop because I like to use R, and I've used it on and off since my dissertation research, and I'm looking forward to applying it in different contexts here. And my favorite fruit, I think I would have to agree with Betty that my favorite fruit is also mango.
Great. Cassandra?
My name is Cassandra. I am an assistant professor at Mississippi Valley State University in the Masters of Rural Public Policy and Planning. And my favorite fruit is blueberry.
Ooh. Pallavi?
Muted, yeah. Good morning, everyone, and my name is Pallavi. I recently finished my PhD in Public Affairs from Florida International University, and Dr. Sukumar Ganapati was my advisor. And I have joined as an assistant professor at Nova Southeastern University in Public Administration. And I'm interested in this workshop mainly because I wanted to understand the cyber and technology space in local governments, and of course, from the policy perspective. And also, I'm interested in the favorite fruit. My favorite fruit is, of course, mango. and definitely from the Asian, and I would rather say Indian mangoes.
Great. Lilia?
Hi, good morning, everyone. My name is Lilia Silvera Minaya. I'm a graduate of the Public Policy Administration program. The name change, I always have to go back and make sure what it is. But of our FIU, Dr. Ganapati was actually the program director who recruited me. So I'm very glad to be here. And then Dr. Giri is my former boss slash friend, so it's double joyful. I'm interested because in our program, I only use data, and I have recently appointed as director of operational analysis at FIU. So going through millions and millions records of data, and as it turns out, Stata is not used. They use R and other tools. So I just want to get a sense of what R is. And being a Dominican from an island, my favorite fruit is banana.
I see Karen, Lucy, and Jocelyn. So let me get to Karen. Jocelyn?
I'm from Parable Support. I'm just like the tech
Oh,
support.
yeah. Lucy? I guess she's on the call, but
Hi, I'm sorry. My
Hi.
internet cut out. Did you call my name?
yes.
Hi, everyone. I'm Lucy Sorensen. I'm an assistant professor at University at Albany in the Rockefeller College of Public Affairs and Policy. I mostly work with education administrative data, but I've also used some data scraping. So I'm really looking forward to this workshop. And my favorite fruit, which seems to be popular in this group, is mango.
Ooh, so looks like mango is the fruit of the day. Great. So what I'm going to do is to just give a very short introduction, and this is essentially
Sukumar, there were two other people as well.
Yeah, that one.
Who did I miss?
Vernice, maybe, and
Vernice. Yes.
And Yanbing.
Vernice and Yanbing. Okay. Hello, Vernice.
Okay, I'm going first. Okay. Hi, everyone. Sorry, I had some little issues this morning. My name is Vernice. I'm a third-year PhD student at Florida International University. I was briefly exposed to R during the ICPSR summer workshop, and I'm interested in learning more. So every time I have the opportunity, I often like to learn more. And my favorite fruit is, I love fruits. You have cantaloupe, banana, strawberries. I love anything that's fruity. So as long as it's healthy, yeah.
Great. Yanbing.
Hello, everyone. My name is Yanbing Han. I'm a fifth-year PhD student from FIU. I'm studying public budgeting and finance, and I'm also really interested in R and Python and all the data science things. My favorite food is orange, but definitely with Blue Moon beer. So that's it. Thank you.
Excellent. So I've hopefully not missed anybody else. That's great. So the fruits, we have a variety of here, especially living in South Florida. We are in Miami, as this would show, and mangoes are very common out here as well. So let me just give a very quick intro to what we are going to be doing today. And as I said before, this is a part of our NSF project, which is on cyber infrastructure training and policy informatics. We are having various activities in the project, And one of the main big aspects of what we are having in this is the use of big data, the analytics, and its collection of data for public policy as well as administration. So what we have for today is what we did just now with the introduction. And then for the next, Dr. Giri and Farzana hopefully will team tag for the next session on the data science, giving a high overview of what's possible in applications. Then we go to the main part of it, which would be led by Dr. Cheng, doing the hands-on workshop. We sent these files on RStudio R and the data we'll be using beforehand. So if you are able to follow through on with us, that's great. If not, you can see what's there, and we can talk about some of both the pedagogical and the research aspects of how we can apply this in public policy and administration. And last but not the least, we want to have your input on how we are able to apply these to our own research agenda and our own teaching schedules and research methods or other classes. So the cyber infrastructure is not a new term. It is almost about a couple of decades old, but it has become more forceful in the last 10 years or so, where it really refers to what we have in terms of the internet infrastructure. But here, the internet infrastructure is added with additional capacity. So when we are saying cyber infrastructure, it's mostly advanced computing. So this is a kind of the basic infrastructure now, as we say, for the next generation of knowledge creation. So if we are talking about the artificial intelligence, about blockchain applications and other kinds of applications, a lot of them require high capacity, and that's where the cyber infrastructure comes in. It's both hardware and software. So that's where some of the melding points are for the cyber infrastructure per se. I'm not going into the details of what that is. It's just giving a high overview. Coming to our project itself, what we did in here was to make a case with NSF that we have not had enough of an emphasis on cyber infrastructure in public policy and administration, and that we really do need the kinds of tools, advanced tools for our data analysis and for evidence-based policy making, especially because as we all know in public policy, administration, management, any of our fields we are in, that we do collect a lot of data. Local governments collect a lot of data, state governments collect a lot of data, federal government collects a lot of data. And with federal government, there are a number of repositories, but there are not as many repositories for state and local governments. So our idea here was to focus on the state and local levels, subnational level, and to curate some of the big data that comes out of the local and state governments, and then make it available to researchers in very systematic ways. So here we are creating this policy informatics data repository, which we have started already with the 311 data. I'll get into what the 311 data is in a minute, because that's what we will be using. And we have also other aspects in the data repository, especially with respect to public meetings and other kinds of text documents, where we are curating all of these data from the open meetings. All of the public meetings are open and they are recorded. So the videos and the meeting texts are available. Here, especially with the part which we'll be dealing with today, we are dealing with the cyber infrastructure training with respect to the big data. Part of what we have already done is to have these data available on high-performing clusters. These are HPCs. So within your university, you may have already these HPCs, which are typically NSF-funded big storage and big analytic arrangements. And they have all these tools like R, MATLAB, and other tools available there. And they're not being used as much as most of the universities would like to. So that's where a lot of the emphasis on data analysis, data use, and using that for evidence-based decision-making lies. And you may appreciate this as well, that although state, local governments collect a lot of data, we are not really using that for decision-making purposes as much. So our hope here is that we use the data that we have collected for decision-making rather than let it lie somewhere in the dark corners of the computing world. Coming to the 311 itself, which is part of what we will be dealing with. Some of you might know already that these are the non-emergency centers, which are very similar to the 911 call centers, but 911 are meant for emergency purposes. 311 is meant for non-emergency purposes. So they collect a lot of service requests. These service requests come through various ways: the phone, the web, social media, and so on. And there are many, many cities that do have these 311 centers. So we have started to curate these data, and we have data from almost 20 cities, which we have in our HPCs already. And Farzana and many of our other students who are working on this project are helping us standardize and get this prepared for analytical purposes. There are many, many research questions also possible in this. So this is a very high overview of what the project is about and what we are going to be today, what we are going to be doing today. And what I'm going to do is to turn it over to Dr. Giri. Giri, if you want to share your screen for your part of the thing, that's fine too.
Okay. Yeah, I think that would be best. Yeah.
I'll stop my sharing.
All right. There you go. Since I couldn't get the chance to tell you about my favorite fruits, I thought I'd find a couple of pictures for you. I don't know if you're familiar with these. The one on the right is a dragon fruit, and now they're growing it in Florida. The one on the left is called mangosteen. If you haven't tried these, you need to figure a way of tasting them. So thank you, Sukumar. Thank you for setting up the stage for what I have to say. My goal is to give you some kind of an overview of data science, so that you will be able to put in context some of the things that Dr. Cheng will speak of after me. So let me get started. The first thing that I want to do is to try and preempt some questions about what is data science, how is it connected to this AI and machine learning thing. So let me start by saying, first of all, what is data science? Well, more than answering what is data science, let me say that we are drowning in data in some sense. In fact, the statistics show that maybe roughly 90% of the world's data that's been collected was generated just in the last 5 years, which to me is staggering. But maybe it's not surprising given that that a lot of this data probably comes from cameras and sensors and social media. And now there's also a sizable growing body of data from administration, from policy related things. People have started collecting this almost as a habit, hoping that at some point all this data would become valuable and would start to make sense for us in terms of how to move forward. The picture on the right shows you how data science is connected to artificial intelligence and machine learning. So first of all, you've also probably heard the term big data thrown a lot. That's just a part of data science where the data is, as the term says, big. There is no precise definition of big data. It's typically the techniques that people use for doing data science, for doing data analytics are sometimes a little bit different when you're dealing with really, really large data sets. We won't have a chance to talk about that, but if you have questions, I'm happy to answer them. Now, artificial intelligence is in some sense much older. It's probably about 60, 70 years old. It started off as a collection of strategies for people to try and do things that are not how do I put it, that are not that seem to mimic human intelligence. And that's roughly the approach. Farzana just pointed out I should put this in presentation mode. Let me see how this goes. Give me just a second. So artificial intelligence, as I said, started off with the attempt to mimic human intelligence. But then over time, as the promises it seemed to have made did not come to fruition, it sort of languished for a long time without seemingly making huge progress. But then this area of machine learning suddenly took off. And over time, they realized that a lot of the techniques within machine learning are really part of what you would call as artificial intelligence. Even in machine learning, there are many techniques that seem to mimic human intelligence. And then machine learning also had a few small successes at the start. In the last 5 years or so, a part of machine learning, especially the part that deals with neural networks and deep learning, suddenly took off and made huge impact in specific applications like facial recognition, handwriting recognition, very specialized tasks that's typically the domain of just human beings. So that's where some of these areas became important and came to the forefront in some sense. So overall, data science has become much more important because of the spectacular advances in machine learning and deep learning. But even besides that, data science did exist as a part of statistics in a lot of ways. Whatever statistics does can be called as data science. Whatever data science does could be called as statistics. But you'll see that there are some minor differences with how statistics is different from machine learning, and I'll speak to it in a couple of minutes. So that's roughly the layout of these domains, so to speak. If you have questions, I'm happy to answer them.
Giri, very quickly, if you press F5,
that
would get to the full screen.
It is already, right? Is it not full screen right now?
No, I think we are still seeing the same window.
I shared the wrong screen. Hold on a second. Yeah, okay. I see, my fault. Yeah, I shared the wrong screen. So give me just a second. All right, there you go. All right. So I wanted to say a few words about how machine learning techniques are different from classical statistics, stats techniques. The one thing that you will see often is that there is in statistics, typically you have very explicit models. You start with a mathematical model, and then you work your data into it and predict various parameters. On the other hand, in machine learning, often there is no explicit model. You try to build architectures like a neural network or some other models where there is no, you may be hard pressed to find an explicit mathematical model. And often what you'll see is that the main difference is in their focus. In statistics, it's often inference. In machine learning, it's often prediction. In statistics, you often want to get the model right. You want to understand the relationships between the parameters. In machine learning, often you want to be able to predict an outcome, and your goal is mainly focused at trying to make those predictions as precise as possible. Often the statistical approach is more interpretable because you have a better understanding of how all the factors and the parameters are connected. Those models were not built to be predictive for data sets that have not been modeled, whereas machine learning is focused on making it more predictive, and in the process, often it pays a price and ends up with less interpretability. In statistics, often there is a very clear experimental design and how you collect the data. In machine learning, often you just say, hey, this is the data that I have, let me see what I can do with it. So often there is no explicit experimental design, but the computational process, on the other hand, typically has these phases of training phase and a test phase. And in some machine learning techniques, you would also see an intermediate validation phase. In statistics, often you go with very strong assumptions about the model. You may have some normality assumptions. You may have other assumptions of independence, etc. With machine learning, often you go with minimal assumptions. You let the predictive power come out of the techniques, and you worry less about the assumptions made. In general, at least statistics, the most statistical applications and models don't deal with large numbers of features, but they assume that there are large numbers of samples because otherwise your distributions would not be right. Your assumptions may not be valid. On the other hand, machine learning, at least again, there are lots of because there's a strong overlap between the two. Many of these statements do have exceptions, but in general, with machine learning, you deal with at least classical machine learning. You deal with fewer examples, but lots and lots of features. But of course, there is this area of deep learning now where you not only have lots of features, but you also have lots and lots of samples. Sorry. Was that a question? Okay. All right, so let me continue. Here's an example of how you go about working with classical statistics, you decide on a model, then you test each of the features to see how valuable they are, how important they are. You compute a p-value for the features to be selected. You correct for multiple testing. Then you compute an effect size for the various features, and then you report sort of the best features. This is a standard approach for statistics. On the right-hand side, you'll see some examples. A through Z are features, and you see which ones have large p-value and large effect size. So of course, the effect size tells you how important it is. Yeah?
The slide is frozen.
It is? No?
Yeah, we are seeing only the data science, AI, machine learning for a while.
Wow, what's going on?
And also if you can use the PowerPoint slides because it's showing the slide on the side as well.
Yeah, we said that.
Okay. All right. So let me just go with this. Sorry about that.
Yeah, now we see it.
So as I said, in classical statistics, you start with a model, you study the features, figure out which one has a large effect size, compute a p-value for these features, and then you report this. On the right-hand side, you see a bunch of features with the effect size on the x-axis and the p-values on the y-axis. So the effect size, if it's large, it tells you that it differentiates the two groups that you're studying quite well. But the p-value tells you how significant that effect size is. So typically you want something that has large effect size and large p-value. On the other hand, if you look at machine learning, you would have a very different approach typically. You pick an approach, you pick a machine learning method. In this case, let's say you pick random forest. You partition the data set that you have into a training set and a test set. You do feature selection to figure out which of the features are best help the machine learning approach. Typically, you also go through dimensionality reduction, which you might do even in the classical statistics. But then you apply a classifier to train your model. I'm calling it a model. Sometimes there is no explicit model. And then you do some cross-validation to figure out how well your machine learning model worked in terms of its predictive power. And then you're free to test it on whatever data set you want. And in many cases, because there are so many different machine learning methods and each one has its own strengths and weaknesses, you can even apply what are called as ensemble methods. An ensemble method, the scenario is that you have a bunch of experts where each expert is a machine learning technique, and then you look at their predictions and you come up with a prediction that tries to combine all their suggestions. I see lots of questions on chat, but I assume these are all from the previous one. Okay. Then the next slides tells you a little bit about where this data science is taking us, all the new opportunities, benefits, and challenges that accrue from it. The first thing that I want to say is that data science can improve the performance of systems. These systems could be the system of a local government, or it could be some other system that you're building. But by focusing on open data standards and data availability and accessibility, they set the stage up for data analysis and for system improvement. A lot of the opportunities that data science provides us has brought about social change and economic opportunities in terms of the ready availability of data. Even if you look at the example of COVID-19, I'm sure many of you were hooked on to various websites that told you where it was the disease cases were peaking and at what time these were happening. And clearly that's a measure of social change, because now we're so much more aware of these epidemics We even know within our city which parts of the city may have more cases, things of this sort. But also this type of social change, besides being disruptive, has brought about economic opportunities. At the same time, it has also brought some educational responsibilities for academics like me and many of you. And it is our responsibility to make sure that that the users are more informed, that they know how to interpret and understand this data. Data also comes with a bunch of challenges. The data needs to be robust. Privacy concerns and privacy laws need to be adhered to. Security is a major issue in some cases. Anytime there is privacy involved, there is probably likely to be some security issues that one has to think about. Fairness is a major point that's now coming up. Whenever you apply machine learning techniques, even though the approach does not have human emotions, it doesn't mean that it was programmed in a fair manner. And so there are lots of questions about how fair many of these algorithms are. Then there are also questions about fault tolerance. What happens if the system fails? What happens if a part of the system fails, et cetera, et cetera. The last point is very, very important. As I mentioned before, a lot of machine learning often is not very interpretable. So there is a huge shift now to building machine learning techniques that are more explainable and more interpretable. Sukumar, you should warn me about time. I know I'm going a bit slow perhaps, but let me know. There are a whole variety of data science topics that are relevant. This is what you would see if you did a data science course. But let me see if at least some of these points I could connect to the domain of public policy. Often when you collect data, you need to summarize them, you need to visualize them. You want to apply some basic statistics. You want to understand this, the data using some clustering techniques or using some PCA techniques. Once you do some initial exploration, then you may come up with some simple hypotheses, and statistics and machine learning can help you to test some of these hypotheses. Some of your data may be time series data where very different analysis needs to be applied, and there are a whole bunch of really wonderful techniques that may help you to look at time series. If some of the data is spatially has spatial properties, then spatio-temporal analysis may be necessary. Here again, public policy data is very much falls into this category of spatial-temporal, has spatio-temporal properties. In many cases, you also want to understand the entities as networks and try and understand how these various entities are related to each other. In many cases, you want to do causal inference, where you want to know how one factor is affecting another factor. Often you know that these two things are correlated, but you don't know whether one is causing the other or the other way around. We've all read that red wine is good for us, and that it's associated with lowering cholesterol. But whether red wine is a cause of lowering cholesterol is something that would need to be proved, and you would need evidence and proof techniques in order to achieve this. In data science, you also learn how to deal with text. Social media, for instance, provides a lot of text, and analyzing these text, this corpus of text is very, very important. Image and video analytics are becoming very, very important, just because there are now billions of cameras all over the place that are collecting relevant information from which one could turn into analytics. Anytime you do analysis, there's questions about outliers, but then some of these can turn into big data analytics. You could also do web analytics, especially if you're doing, if you're mining social media data. And then data science often also deals with stream analytics, where you're assuming that the data is coming in as a stream. You can't really store this in a permanent, well, you can store them in a permanent place, but trying to analyze them after they're stored could be too late. You want the analysis to happen very quickly. So for instance, something like Wall Street data, unless you act quickly, some of those opportunities may not stick around. And in such situations, you want to do stream analytics. So this is a potpourri of topics that one would see in data science. Some of these are very relevant to this domain. But if you have an opportunity to learn more about any of these fields, any of these sub areas, that's something that could be useful for you. In terms of programming resources, it's important to understand that a lot of the basic analysis one could potentially do just with Microsoft Excel or with some spreadsheet type software. But if you want to do something more sophisticated, you may want to get commercial software like Tableau. But in terms of freeware, Python and R provides you with unlimited abilities to do a variety of things. Python can be run on your own laptop by just downloading this environment called Anaconda, and R can be executed on your own machine by downloading RStudio. These are wonderful environments for your laptop that will help you to experiment with small things before sending some of these big experiments to maybe a high performance computing environment. There are, of course, other languages that are possible, and I mentioned them: Stata, Ruby, MATLAB. But for now, at least Python and R are the primary tools for a lot of the analysis, and the threshold for getting into this is actually fairly low, and you can start to work on this fairly quickly. This is just to tell you that Anaconda and RStudio are the two popular environments to help you to run Python and R programs. Both these environments create what are called as notebooks. These notebooks are a fairly recent invention. They help us to, and you'll see an example with Shaoming. He's going to show you a wonderful notebook. I believe that's an R notebook, which will show you how you go through various steps. And if you follow that notebook, you yourself can do a lot of the analysis with effortless ease. It's possible to share these notebooks. Here on the left side, you have an example of an R notebook. On the right side, you have an example of a Python notebook. Not only do you have pieces of code, you also get outputs, you get figures, and you can save these as notebooks and share it with people. Then finally, I just want to end with a comment on high performance computing. This is something you will need either your university or your institution to provide you an environment. There are many R packages that are well tuned for these high performance environments. Same is true with Python. Many of them have built-in implicit parallelism. Many of them can also exploit, if you have a quad core processor, many of these programs can exploit even that local computing power. But if you want to use really high performance computing power, then you could go to environments, and then there is something called Revolution R, and Python has other tools related to MapReduce, Hadoop, et cetera, that will give you enhanced power to analyze large data sets. That's all I have for now, but I'm more than happy to answer questions, and I give this over to Sukumar to tell us what's next.
Thank you, Giri.
Thank you.
Yeah, this would be a great point to take any questions, thoughts, ideas before we move on to Dr. Cheng's?
I see here a question, can you use SPSS? And Farzana has answered that. SPSS is commercialware. It's at this point, R has almost unlimited ability. It has almost every feature you would see in SPSS is now incorporated in the free version of R.
I'm not sure what is the protocol to ask question.
Please.
We do have the SPSS license at the university.
Yeah.
And I'm teaching, statistics, research method and statistics. And I feel like, so I never use R yet, but you are teaching a public policy school. Do you see that the students with their background in public affairs are able to be comfortable using R instead of SPSS? Because I have a lot of challenges using SPSS with my students. I'm not sure how about R. Thank you.
I think Sukumar and Shaoming are probably better poised to answer this question, but let me just put in my personal bias. R is freeware, and it allows for you to write your own programs and share with people. Sharing SPSS is not that easy unless the other person also has SPSS installed on their machines and so on. R is where the future is. I think there's almost no doubt about it. You can talk to statisticians and they will probably agree with me on this. At least in terms of statistical software, R is definitely the way to go. It has also grown in terms of the packages and the ability and the graphics and the high performance computation part that is made available to it. Sukumar, Shaoming, you want to add to this?
I think, well, thank you for the question. I think it's very relevant for teaching in public policy, public administration. I agree with what Gary was saying. So everything in SPSS that are available in R, you will find comparables even better in R. But more importantly, SPS and R are for different purposes. So SPSS is for statistical analysis. R here, for the later on kind of the hands-on workshop is for machine learning. So many of the machine learning algorithms are not available in SPSS. So back to your question about teaching students, we are, at FIU, we are actually not using SPSS data for statistical analysis. In our statistical course, we're using Excel. So I think that's to have a lower threshold for students to learn statistical analysis, to have those exposure, because very often for a master level course, those functions in SPSS or Stata, those are available in Excel as well. We're proposing a machine learning R course for the first time for spring 2021. I will just keep you posted on how students may react to using R in a machine learning.
Dr. Sukumar, would it be possible? I am really happy that NASPAA had this workshop today. And and I know we have been talking about data analytics, big data, which is really now even a concentration in public affairs. So, and we have global security concentration as well, with data analytics is really critical. So can I register for audit your class? That way I can see how can I need to feel comfortable using R before I can use. So I'm not sure if maybe I can send you an email and a separate email to see how I can audit your class to see if that's possible. Thank you.
Yeah, that's a good point. We can talk about how we can open it up. And I guess because we are remote, we should be able to do that. And that's a great point, both Giri, thank you, and Shaoming. Because R is freeware, it's available with a lot of support and a number of packages which people are developing as well. That seems like would be the package of the day. in the future.
Why pay for something that's free?
Correct.
I also wanted to, another thing is that I think many universities actually use different tools, like one of them use SPSS and one of them uses Stata, and they are all like commercial. So like when you are like going to a common platform and want to share ideas, I think that becomes painful because not everyone uses the same tools. So there is not that interoperability between academics. So I guess in that case, having a common thing like R, which is like anyone can use, that will actually add more flexibility to the process.
I see Cassandra and Michael also have good questions in the discussion. That's part of what we are getting into, I guess, next in terms of packages and how do we apply this to our own context in our schools.
Yeah.
So we sent the files for installation. There are, I wonder, if you could indicate by the reaction with the thumbs up button, if you were able to install R and R Studio, and if it was easy enough, that would be great. Then we can have a sense of, how many of you have been able to do that. Was that difficult? Was that easy?
I've downloaded it over the summer. I've had it on the for ICPSR workshop with R. I think it was difficult for me at first because you do have to do R and R Studio for it to be able to work. So I tried downloading it. I think once you have it and it's you can follow along, it gets a little bit easier. But if you're using it for the first time and you haven't used it before, it can get a little bit confusing, at least on my end. But if it's something you were exposed to, then I think it's easier for you to follow along the second time.
That's great. Shaoming will go on next. You'll see there are some very common packages that are used along with R and R Studio. We asked for some of those common packages to be installed along with this. So, Shaoming?
Yeah, thank you. First of all, thanks for the introduction provided by Sukumar and Giri. I think that's a perfect for my part of the discussion or the workshop. If you could see my screen here. So we were able to send you this notebook, this R notebook, and a very small data set in Excel just before the workshop. And we're hoping you're able to get a chance to install R and R Studio because those are the software we'll be using today. So just piggybacking to some of our conversations about SPSS and R. Yes, R is free, R is more functional, R is much more powerful compared to SPSS or others. But there is a learning curve. Sometimes it's a very steep learning curve for people who want to get started. So, I mean, one of the purposes of this workshop is to provide a kind of example, right? A policy example, and to help you to overcome this learning curve, to help you get started. And if you could look at this data set, it's a pretty straightforward data set. It's a cross-sectional data. We have 519 observations. Those number of total census tract. So if you're not familiar with census tract, United States divided by state, then a state divided by county, a county divided by tract, a tract divided by block groups, and then block, so on and so forth. So it's a census geographic unit, spatial unit. So we have 519 in Miami-Dade. So the question is straightforward as well. We're trying to predicting the number of 3+1 requests based on a bunch of a variety of community characteristics. I think many of us can relate this question to our regression kind of background, right? So then you're thinking, oh, it's a cross-sectional, we can do cross-sectional kind of regression. If you are familiar with spatial regression, you say, oh, I can do some spatial regression. Then if you're thinking, why only 1 year? So we can do multiple years. Then you have a panel data set. You can do fixed effect, first differencing. You can even do spatial panel. Or if you're thinking the number of requests with a dependent variable, it could have time, the time autocorrelation. Then naturally it will be the dynamic panel data, or even spatial dynamic panel, so on and so forth. So here, I think, just provide this as a practical case for you to get started, get familiar yourself with R and machine learning algorithm. And this question can become complex or much more complex very quickly, right? So here we're talking about predicting on the annual server request. Then we can, if we get a smaller time interval or smaller geographic unit, then the situation may become much more complex very quickly. We may try to predicting the weekly number of requests or smaller, so not just in the census tract, but also block groups or block. The block is more in line with the community kind of definition. We have a 519 census tract within a county. We had about 1,010 census block groups within the county. We have about 3,000 blocks within the county, right? And also we want to do if not weekly, we want to do daily. And also if we want to do the prediction just in line with the hurricane or in line with COVID-19, we want to predict the number of cases. So the algorithm we're developing, we're kind of practicing or exercising today can be easily just use or apply in a different policy scenario. If we're trying to predicting some sort of the number of requests, number of counts, number of COVID-19 incidents or positive, in a spatial temporal setting. So that's the basis of the the background. We're using this to give you a real life example. For the notebook, right? So if you are able to go over the notebook, so you will see different chunks, right? So those are typically called R chunks. So those are code chunks. So that's a code. So you can either open up your RStudio if you're able to download R and RStudio. You can copy paste. You can copy paste the whole thing, right? Copy paste the whole thing and copy it from our notebooks and paste it in RStudio. Then you will be able to run those code. Or if you prefer to use the notebook directly, we save this page, this file. This is web page file, HTML file in your local drive, right? Then you are able to open up in RStudio. Open up RStudio. Let me open up RStudio. Then you save your R notebook in your local drive or Dropbox or OneDrive, whatever. Then on file, then you can open file, right? Find the folder where you save there are notebook. So in this case, I saved here. So if you click that web page, HTML page, then RStudio will create this R notebook just in your local drive. So you can follow this. So it becomes a local version of R notebook in your RStudio. So then those code, you can run those. There's a little error. There's a little green error there. So you can say it says run current chunk, right? So if you click that, it will run the code in this R chunk, and the results will be right underneath the your R code, R chunk. Just give you a quick example here. Give you a quick example. How come I couldn't move my? Oh, sorry. This is the wrong file. This is the pre-inspection file. So here, right? So here is I can run my R chunk. If I want to use those libraries, I can just click this little arrow, And those are the results. It's right underneath your outcome, right? So here are two ways to use the R notebook. You can copy paste those R code into R Studio, or you can save your HTML file and open that R notebook file there. So if you didn't get a chance to install R or R Studio, don't worry. Everything will be recorded, and you have this R notebook, have this data set, have the recording, so that will help you to get started as well. So I'll have a quick stop. Any questions? Okay, so here is our focus, as Giri was saying, this focus is here is machine learning to get you started. He provided a great overview and compare and contrast between these two approaches. So machine learning is more about prediction. They pay much less attention to the functional form of the features or the independent variable and the dependent variable. But they want to utilize the data, right? And basically to use the data to train the model and also to make a prediction. So let's get started. I see there's a few chats. Let me. The R notebook is, we sent you 2 files. One of them is called FIU NASPAA Workshop, which is a Excel data sheet, right? So that's the data. The other is a HTML file. It's a web page file. We also named FIU NASPAA Workshop R notebook. So that's the R notebook I was referring to. If you click on it, it will open up as a HTML file, as a web page file. You can copy and paste those R code on the R notebook into our studio, or you can save the HTML file on your local drive and open file in R Studio. So you will have a R notebook just running in your local R Studio. Okay, so I assume many of you, most of you have successfully installed R and R Studio and open our notebook, as we were saying. Then the next step is to install those packages, right? So those are the commands. So you can either copy and paste from our notebook, the web page to your R Studio, or you can just click this little arrow here. So those are the five packages. So R is an open software, it's a platform, right? But it's open source. So different users creating different packages for different functions. And for the same purpose, they may have different functions, different packages. For example, random forest, they may have quite a few different packages to run random forest. So that's the benefits and also the obstacle challenges for the open source software. The benefits is that you can almost always find things you're looking for, right? But the obstacle challenges, there's so many packages around there, and they are written by different syntax, they have a different function, there are different parameters, so on and so forth. It can be overwhelming, can be very challenging for you for anyone to understand, to keep track of all those packages or new packages. So that's why, I try to emphasize this carrot. The carrot is very important. It's very helpful. It's a wrapper of many of these packages. So they will provide a kind of consistent and uniform syntax for different functions. So we'll spend many of the time using carrot as an example. So I think that will be like a workhorse algorithm in the future.
Shaoming, there is a question which is in the chat that is, we sent the pre-installation file, and this one is not one, the installation files, I guess there's a mismatch. But main thing here is those particular packages which Shaoming is talking about, those are there in the pre-installation package, in that file we sent, that HTML file.
yeah, it's in the pre-install package as well, and in our notebook. Didn't we send out the FIU NASPAA workshop, both the spreadsheet and our notebook?
No.
I think we did.
No.
No.
In the file section, I only see the pre-installation one, so I don't know if there was any email because I could not find anything.
Yeah, the pre-installation file is what we sent.
It's just a pre-installation, correct? Yeah.
But we didn't send out the Excel, the Excel file, and our
no, the Excel file is also sent. That's separate.
Right. I'm pretty sure we sent those out.
Yeah. So I sent it out both in the Excel file should be.
It's in a zip file, so we zip together the Excel file and the workshop R notebook.
When you see the 311 raw data, that's the top file. There are 4 files in the on the Pathable portal, and the top one, the 311 R data, raw data, that's the data, and the R notebook installation instructions, that's the pre-installation file. But that should work with what Shaoming was saying.
Right. I mean, the pre-installation is only to get you ready. You don't need to. So if you already have our studio, you don't need to worry too much on the pre-installation file. So it's only like a heads up to remind you to download R and R Studio to prepare yourself for the workshop. So don't worry too much about it if you already have R Studio installed on your computer.
Yes, that's all that matters.
So just a quick kind of poll here. Were you able to find the data and the R notebook for the workshop itself? Not the pre-installation R notebook. Yeah. Okay. So I'll give you a few, 1 minute or 2 minutes. So open up. Okay. Still, Melissa saying not getting it.
Do you want to share that main page where that portal is?
Sukumar, do you still have the email address and send them a quick email?
Okay, I'll send it by email.
Right. You can just resend the email you sent early on. So I think email probably easier. Because I don't know where NASPAA put their data set online. So I'm probably not able to, show how to do that.
I can share the screen if you and
yeah,
show it.
Okay, please do.
It'll take less than 30 seconds.
Yeah.
Okay. Sorry about that. So I'll share my screen here, and here's the Pathable site, correct? And when you go on to the files, you will see there are 4 of them. And the 311 raw data is the data that we are using. And this is our instruction installation. So once this one gets to that, it will download that file.
Right, but that's a pre-installation.
Yes. So this is the file that you need, right?
No, well, there's another R notebook on the workshop itself.
Yeah, there is no notebook, yes.
Okay, that notebook, this is the file we shared. So I can send that file by email.
Thank you.
Yeah.
I'm pretty sure we sent out those, but those are not uploaded to NASPAA page.
Yeah, you can continue with that. I will stop my screen share.
Yeah, I'll probably wait here. So, until people receive the R notebook for the workshop and open it. So probably now is a good time for some questions so far.
Professor, I think what we got from the email and also the NASPAA website is the pre-installation notebook. We haven't got the notebook you are presenting now. That's a issue.
Yeah, I think you're going to get an email in the next couple of minutes. Shaoming, while you're waiting, you could perhaps show how you can execute some very simple instructions on the R notebook. Just create one. That way, at least people can see how easy it is to get started.
Yeah. So I'm sending you the zip file. So if you could forward it to everyone.
Yeah. I will email in the next 2 minutes, so you can continue.
Okay.
Hey, yeah, there's something else because this context.
So yeah, so here is well, not this one. So here we're here in the R studio again. So this workshop, R can be used for many purposes, right? So many of you, some of you may have already using R for statistical regression analysis, or it's very powerful for data visualization as well. And also it's very powerful for data transformation or data cleaning, so on and so forth. But those are not the topics here. So here is mainly focusing on some machine learning algorithm, right? But I do provide some resources here if you are, so those are well recognized resources. So if you are thinking about more about data cleaning or data transformation, data management, so those are some of the resources I will highlight here. In 1 second. Right. So here, so those are, in our notebook, there's this link is live. So these are for data science, importing, tidy, transform, so on and so forth, and visualize and model data. So that's a very resources. That's very good resources for you to know more about R, those functions in data transformation, data cleaning, data organization. It's very very useful, and you can download it for free, or you can purchase from Amazon, get a hard copy. But you can download it for free from the author's website. So those links are also there, right? So it's straightforward. So if you download the data, so that's the name of the data, okay? Because I said the directory already. So if you look at on the top, you can set your directory, or you can open up. Right. Yeah, those are the notebook you are. So we're looking at now. So FIU NASPAA Workshop R notebook. So that's the notebook I'm looking at. Oh, and also one thing I want to emphasize is that R is just a additional tool, right? And we are here to use all kinds of tools at our disposal. So if you are familiar with Excel or Stata or SPSS or MATLAB or any other software, you already know how to do some of the data cleaning, transformation, so on and so forth. Don't force yourself to, so we have to do this in R. You already know how to do this. You're already being an expert on doing those in those software packages. So don't hesitate to utilize all those tools at your own disposal, right? So R is just a additional tool for us, right? We are here, we are the master of the tool. We're not a slave of R. Just because we're learning R, we don't have to do all those things in R. It makes perfect sense to go back to what you're familiar with, what you're good at it, the software package to do to achieve those functions you're looking for. Okay, I see people are receiving their notebook, the workshop notebook, and getting the data. So first thing you want to install, if you haven't installed those 5 packages. Those 5 packages are listed in the pre-installation notebook and also in the workshop notebook. So in our studio, try to install those 5 packages. Right? If you already installed those, you don't have to reinstall them again. If you try to reinstall them, you'll get error messages. You're saying, okay, those have already been installed. So that's so you only need to install a package once. You don't have to reinstall this every time you're using R or using those packages. But you have to let people, so after those packages are being installed in your local R studio, right? You have to, if you want to use one of them, you have to let R studio know we're going to use this, right? Then they will just activate those packages. So that's the package, that's the command or syntax used here, library and parentheses. Then we have the quotation mark. Then you're saying, well, there's a double or single quotation mark. To me, it doesn't make much a difference. But I'm probably on a data science perspective, there's some difference there. But to me, it doesn't make a difference. So that's why some are putting double quotation mark, some are single quotation mark. But that's the command library and parentheses, then the quotation mark and the package you will use.
So the only reason to have both is if you want quotes inside quotes. That's all. It's purely a programming issue.
Right. So yeah, unless you do very complicated programming, I mean, for a daily use, I think, yeah, to me, that's not much difference there. Right. So yeah, you wanna use those packages. So if you are still watching the HTML file as a web page, that's perfectly fine. Just copy these R chunks into RStudio. If you save your HTML file already on your local drive and open it in RStudio, then you can click this green little arrow here. So you can see the bar, it's just like a progress bar, and it's still running those, and just let you know all those has been those has been activated, are ready to use. Then we will want to import data, right? So the data is in a spreadsheet format, in a CSV format. So that's very common data format. You don't have to use CSV. It can be Stata, it can be SPSS, can be Excel, can be DFB. So there are different packages for different data set. But this CSV read is just embedded, it's a built-in syntax within RStudio, within the basic function, the basic package here. So a quick kind of explanation of the syntax, right? So the read.csv, that's the command, that's the verb R use or RStudio use to do this, right? You have a parenthesis, and you have the quotation mark and the name. Because I said the working directory already, so I'm just read this file directly, right? If you didn't set the working directory, you have to find the path. It could be C, comma, user, your name, Dropbox, so on and so forth, right? put the whole path into the quotation mark, right? And don't forget to end .csv because it's a signal to the file. I'm reading a CSV. And here, this little smaller plus a dash, so this is called a sign. So that's it's a kind of unique kind of way here. I think you can use equal sign as well. Again, to me, it doesn't make much a difference, but there may be a difference from a programming point of view. But I think just follow the more kind of orthodox training or the language you want to use your sign. So here is, we are creating this new data frame, right? Here is data frame is a data. So that's a particular name for our students, data frame. So this is a data or the data set. We're reading this FIU underscore NASPAA workshop, so on and so forth, CSV file. We read the CSV file into this data frame, right? So the count underscore 2014. That's the data being created within your R environment, within the R student environment. So if we click on this, we can run this all together. Right, so we're reading this. So here the data frame gives us some of the summary statistics. We have 519 observations, those corresponding to 519 census tract. We have 51 observations, 51 variables. So those including both the dependent variable, the outcome variable, and the features and the independent variable. So we have a total. You can just think about either in Stata SPSS. You have a 519 rows with 51 columns. So those are the structure. If you put in the structure is another verb you use. Structure, for instance, the count of 2014, it will give you the structure. So those are structure, give you the nature of the data, either integer or the numerical or some of the factors here, right? And also this is summary. Summary gives us the mean, the standard deviation, the first quantile, so on and so forth. So those are the summary here, right? And here the dim is the dimension. So dimension, again, if you put the dimension here, so it will report. So that's still the summary. That's the outcome. That's the result from the summary, some of the data. So here it is the result from the dim. Dimension. Dimension tells you have 119 rows and 51 columns. So when you are trying to see whether the data has the same number of columns, particularly when trying to merge or combine or arbine or those data set, you want to know whether they have the same size, same number of columns. So it's a very helpful kind of verb. It's a dim, the dimension, right? So once you reading the data, then we want to do the machine learning. So the machine learning, as Gary, in his introduction, we do not have a functional form. So for the independent variable, for the features, right, to predict the outcome, we don't have a functional form. What we do is we try to split the data or the partition of the data into two sets, typically 70-30 or 80-20. Right, we're using the 70% of the data or 80% of the data to do the training. We train the model, train the algorithm, right? Then we use the train algorithm and to test the accuracy, the predictive accuracy using the reserved testing data, which is the 30% or 20% of the original data. So that's the typical step, the typical procedure. So the first thing is we want to split the data into two sections. So here is 70-30 split, right? So here is we are using, so this is part of the carrot package, right? So if you do not want to use carrot, there's other package you can do the split, the data partition. Oh, sorry. So here the first one is feature selection. Okay, I'm just jumping ahead. But the feature selection. So what is feature selection? It's more about if you're in a regression setting, right? Many of us are from a regression setting. the regression setting, one of the assumptions is the independent variable themselves are not strongly correlated, right? So otherwise there's a multi-correlarity issue. But that's a violation of the OOS. So just thinking about overfitting or feature selection is similar to the multi-correlarity issue, right? The only difference is that in regression settings, multi-correlarity, we're not able to identify individual effect of this, of these variables because they're correlated together, right? So and the model will become inefficient, sometimes becomes biased because the t will be statistics will be just overestimated and the p-value will be much smaller. So those are the limitations here. But for feature selection, typically if you do not do feature selection, the consequence is overfitting the model, meaning the model, the trained model becomes too specific to the data set the data set being trained, because many of the features are correlated among themselves, right? So here is we're trying to reduce the those correlated variable, and also trying to reduce the likelihood for overfitting. And also we are so if a big data set, we're able to reducing the time being spent on training the algorithm. So feature selection is very important step, particularly if you have a large data set. So here is we're using this package called Baruda. So Baruda is, I think it's Indian words, is the god of the forest. Why is that? Because Baruda is based on the random forest. So based on the random forest procedure. So because they're the god of the forest, they're able to pick and select those features here. Here, because you already installed Baruda, right? So here the basic command for Baruda. So the Baruda, then the count. The purpose is here is to predict the number of counts or number of requests through our requests, right? In each of the census tract. So the count is outcome, right? In a regression setting, it's the dependent variable, the DV, right? And that's the outcome variable, dependent variable. Then we have the tilde. Tilde is separate the dependent variable and so-called features and the independent variable. Then the count, the outcome variable, tilde, they have the dot. So the dot is we selecting everything, right? All the features in your data set. If you want to use all the data features in your data set, right? You can just set Baruda count tilde dot. That's it, right? But here is we want to minus some of these variables, right? Because some of the variables are not really helpful to the name of the census tract. So what we did is we minus, right? So if you want to add something, you plus. If you want to add minus something, you minus. Minus the name, minus the GeoID. The GeoID, the census ID for each of census tract. So we think, well, it's not relevant. We minus the year because they're all from the same year, 2014, right? So it's a count outcome tilde all the features in the data set. And we minus the name of the census tract, we minus the GeoID of census tract, we minus here, right? So that's all the features will be used here. It's all features except name, except GeoID, except year. Everything will be included for the feature selection procedure. And the data is based on what? Based on the count underscore 2014. So that data frame we imported from the Excel file, right? Then we have do the tracing equals 2. You can just copy this, do the tracing equal 2. Here's to give you the report for each of the steps here. And max number of run is 500 times. So here is, we'll run the procedure 500 times. Then we'll report you some of the features are important, some are not important. So I will click on here now. So it start running. You can see the status bar here. It start running because it's based on random forest. So what the kind of procedure or the process behind the scene is, they're trying to build up the random forest. follow the random forest kind of procedure step. Then they will try to compare, whether including a feature, not including a feature make a difference based on the certain predetermined kind of threshold. So it will run 500 times. Either they run through all 500 times, or if they're able to make a decision, some features are make a decision for all the features, they will stop the process before 500 runs. So while it's running, I think it's a good time to look at some of your comments and questions. Let's see what questions. Any questions you have? So I think many of those are comments in the chat, and also being answered by Sukumar, by Giri, by Farzana.
One question which is kind of related to this, what you're saying, which Aziza asked, is this looks like stata. So what would be the added value with R over stata?
Right. I mean, Baruda doesn't exist in stata. And just many of the the forest, the random forest, SVM, the support vector machine, those algorithms, they do not exist in stata. So again, stata SPSS are meant for regression analysis. You can do regression in R for most of the cases, probably for all those situations. But here, this machine learning algorithm do not exist, or they're very limited in SPSS in stata. So those are really many for different jobs. So here is we're just look at this from a different angle, not from a traditional regression context. I try to relate this question to regression, right, to give you some kind of connection here. But here is really a different way to look at the data to make prediction without resorting to any of the information or the knowledge you have in stata. The only reason I kept mentioning stata or SPSS is try to relate what we're doing to a regression type of setting.
Professor, I had a question.
Mm-hmm.
So when we are using R instead of course, stata, because stata mostly probably would do more of the statistical analysis. But when we are doing the R, all those statistical analysis and then wanting to use the machine learning aspects. So how is that? How is it streamlined into the R, the machine learning part of it, along with the statistical analysis which we do?
Well, we haven't, here, I mean, this workshop is purely on machine learning. It's an introduction on machine learning. So I'm not using any statistical or regression analysis. Here, you're looking at it here just basically the summary of the data, right? So it doesn't matter you're looking at machine learning or regression analysis. You want to know your data, what the data looks like. So I think that's if you're saying here that you look familiar, exactly the case, because it doesn't matter what you're doing. You want to know something about the data. What's the summary statistics? But that's all the connections you have, because Baruda, because support vector machines, or those random forests, those ensemble prediction, those are really independent from SPSS or stata.
Okay.
You can do regression, you can do panel, stata, you can do, spatial analysis regression in R, but that's a totally different topic here. So here is on machine learning. So I mean, the biggest difference, one of the biggest difference, as Giri was saying, there's no functional form, right? We're not talking about what's the functional form of the independent variable on a dependent variable. So we don't have those individual coefficient or the p-value or the r square. Well, we may have r square, but we don't have the p-value of individual coefficient. So those are the focus of the regression analysis, right? We try to infer, because we're doing with a sample rather than the population. We try to do the inferential kind of statistics. We want to know from the sample to the population. But for the big data, so that is really in the back burner. We don't care so much about the p-values. What we're really concerned about, or focused about, want to learn about is a prediction. We want to predict based on the data, because machine learning or data science, typically they're working with very large data set, right? So even if they're not a population or a universe, p-value doesn't make sense anymore, because p-value will be statistically significant, probably in all those kind of incidents. So what we most concerned about is about the prediction or the accuracy of the prediction.
But Dr. Sorry, Dr. Would it be possible, I know you said this is the purpose of the workshop is machine learning. Would it be possible for to run a regression prediction just to see how it works? So is that beyond the scope of this workshop?
You can as well, as I said at the very beginning of the workshop, right? So those are data. So it's a cross-sectional data. You can run cross-sectional regression. You can run spatial regression. If you're thinking about multiple year, there's a panel. You can do dynamic panel if you're worried about serial autocorrelation in the dependent variable. You can do spatial panel. You can do fixed effect panel. You can do first differencing panel. You can do, yes, sky's the limit. Here is just offer all the participants a brand new approach, a brand new perspective looking at the data, right? Which is machine learning perspective. It's a complementary to what you may have, what you have known in terms of regression analysis. But here, just give you a new perspective.
Yeah.
So just a follow-up question, Professor, what you just said, that when we are using the data are here for the machine learning purposes. So just to have a understanding of how the data really looks like. So going a step beyond it would be like using some additional machine learning methods to analyze the data, something of that kind, the machine learning space. That would be the next step.
No, that's a part of the workshop. So the machine learning, the first one is you want to select features, right? So you want to, it's like a regression. You want to know what independent variable, what X variable should be included, right? They want to, so some of the step is you want to look at the correlation of those independent variables, right? To see whether they have a high correlation, whether they have a multi-connectivity issues. Look at the distributions, whether they have a follow normal distribution, whether you want to take a log, so on and so forth. So that's the feature selection step in machine learning, right? But instead of you as a researcher to do those like manual or to do those at your own discretion, here is you have a steps there. So they will help you to select those features based on some preset kind of criteria.
All right.
So you are going to see the complete machine learning process. Dr. Cheng is going to show you. He's just preparing for it.
Right. It just, this feature selection takes, a little bit longer time than we thought because it's it's a 500 rounds. It's that's the limit, some of the limitations of the random forest. So now it just spits out this result, right? Because you use the do trace number 2 to do provide us all those results, right? So they are providing all those results here. So you can see we have run those important source. We're confirming some of the features. Those are important. Those are not important. So those are really based on the Baruda function, right? So based on the procedure within Baruda. So we are able to decide not really based on the researcher, right? So it's like autocorrelation among independent variables. Is is 50% high or low, or is 65% high or low? That's very subjective. Here is not subjective. We're based on all the procedure built into the into this. So that's the first step. It's just like you are selecting independent variable for regression. Here it's the same. You are selecting features, right, for the machine learning algorithm, right? We're not build up a regression model. You can, but we're not going to. So here is, you can see after 384 rounds, right, it stopped because they're able to confirm they're able to make a decision on all these features, right? So some are being selected as important, some are not. So if you run this chunk, you're able to see here. So we spend 10 minutes running all this procedure, right? And 28 of the attributes, meaning features or independent variables, are important, and 19 are unimportant, right? So that's the conclusion. After the Bermuda setting. So here is like a graph, right? So you can see what are important and relative importance, right? And the red ones are unimportant ones. So they're able to reject those. So here you can get the specific ones, they are important or not, and you can get the summary statistics, the range, so on and so forth, right? And here is we're able to, so if sometimes after 500 rounds, you get things that are not 100%, you're able to just say, okay, based on information here, so you can select either, I can select only confirmed features or non-rejected features. So it's really your decision. And I'm a little bit running short on time. So then you can select, you can ask them to provide all those features that are important based on the feature selection algorithm, right? So here you can see the count is outcome variable, right? The count and tilde, which is equal to all those features. You can see they are all connected by a plus sign. So meaning we have the first feature is total number of housing unit, right? Plus one, kind of one units housing, one single family housing unit, right? We have the rental units. So those are the features, community features we're looking at. So those are the training model will look like, right? Training model will look like. This is a step here is you can just copy paste this into your training algorithm. There's nothing wrong with that. Nothing wrong with that. It's perfectly fine. Here's the additional step is we want to assign all those into this so-called feature variable. While we're doing this, because it will be helpful for kind of automation in the future, because all the training algorithm will stay the same. In terms of the outcome variable, in terms of the features, right? Because we all call the feature 2014. Any changes in the feature, you can make changes here. Then all the rest will stay the same, right? You can all use feature 2014. So here you just assign this relationship. This outcome variable is count, and all those features assigned to the feature 2014 variable. Then we do the data partition, right? I mean, the training is about training. It's, machine learning is about training the algorithm and also test the algorithm to see whether there's about this accuracy. So we are using the caret help us to do the partition here. We are set the seed. So that's a random seed generator. We are, so the create partition, so that's the verb. We are based on the count variable, based on outcome variable, right? We're select 70% of the data into this index, the partition index. Then we're creating two training sets, two data sets, which are subsets of the original data set. We have the training, you can put any name here, training 2014, right? It's the count 2014 data set with all the partition index, right? The comma meaning all the number of rows. And then we reserve the 70% is the testing data set, right? We have the 2014 data set. We have the minus meaning the remaining into this. Then comma means all the columns here. right? So that will happen for every data training procedure. Then the train control, that's also in Carrot. So Carrot has the uniform, consistent kind of the command, the syntax. Train control, that's the verb using. We're using so-called repeated cross-validation. So cross-validation, what does it mean is for the training data, right? Well, here is a number of 10 times, repeat 5 times. Meaning is for the training data set, which we created, which is 70% original data, will further divided into 10 subset, right? And each time we'll reserve one of the 10 subset for training, for the internal training. We'll run a training procedure for the 9 or using the 1 for internal testing. We take turns, right? For first time we reserve number 1. We run 2 to 10. The second time we reserve number 10. We run the remaining. What that meaning for we'll run 10 times. That's a cross validation. Repeat 5 times. We'll repeat the 10-fold cross validation 5 times. Meaning we're using the training data set, 70% original data set. We'll run 50 times, 10 times 5, 50 times to do the training. The purpose is we want to reduce any idiosyncratic things when we only do one random selection. If you do not want to do repeated cross validation, if you want to do cross validation, here's the command, right? It's only CV, not cross validation. So I think we may only have time to do the supporting vector machine. So that's a machine learning algorithm, right? So we have random forest, we have ensemble thing later on, but let's do the support vector machine here. So that's the
one. Just 10 minutes left.
Right. Let's just do one. So that's the verb train, right? The feature 2014 is the outcome and the feature. We predefine. So here are the data. What data we're using? Train data. We're not using the POM 2014. We split the original data into 70% and 30%. We're using the training data. We reserve the test data 30% from other purposes. And the method, what we're using. That's SVM readout. So that's a form of support vector machine here. So support vector machine is different from linear, kind of a linear algorithm. It's because you're able to use those high dimensional data because you can take those features into square, into cube, into n time, into n. So you're able to get this high dimensional data there. Then the train control is, we define train control here. We're using the repeated validation, and pre-processing is we want to standardize. So people are familiar with the Z-score, right? So we want to center it, we want to standardize. So we're divided by the standard deviation. So that's the pre-processing. You don't have to do it. It will improve, improve the speed. So if we click on this, so that's the training setting. We do not inform or impose any sort of structural formulation of independent variable. So they can test different squares. You can test, house unit square or cubicle, so on and so forth. So here is so-called the variable importance. Again, we're not reporting coefficient. So those are not coefficient. Those are relative importance of those variables. Which variables are more important relatively into making the prediction, right? So here is, we're asking them to do the prediction. Here are the prediction. So those are for each of the observation in the training data. We ask them to do the prediction. So that's a prediction. And also we ask them to compare R-square. There are many ways for the accuracy. I'm using R-square because so people can really relate it to the regression setting. R-square is to see what the variations can be explained by the features included by the independent variable included. So here is 95%, which is not bad, which is pretty good. So due to the time, I have to stop here. But But I hope this gives you some kind of overview of the machine learning procedures, and all the other things random forests are very similar to the support vector machine. I'll just turn the time to Sukumar here.
Thank you, Shaoming. That was great. This is kind of like involved. So apologies if this is kind of a little bit rushed. 1 hour is short for this kind of a thing, as you can see. Any quick thoughts or questions on this?
Hi, I know you have this workshop is sponsored or funded through the NSF grant that you have at FIU.
Correct.
So would it be possible? I know I asked too many questions. I already asked to be part of the class. But the second request that I'm asking you, all of you, distinguished, professors at FIU, would it be possible to have a follow-up, whether even a paid, I don't know how you can do that, but I really would like to have hands-on. It was, we're going through the pandemic. I don't want to go into details. I spare you that, but I really would like to have a follow-up for those of us who are interested and how we can do that.
Yeah, that's a very good point. Yeah, definitely. If there's more interest, that's great for us. Yeah, we can do that. Absolutely. Any other? I know people have to jump off for the next meeting, but I do want to thank you all, and most importantly, Stacy Judy also. Stacy is the host of this meeting. Stacy, thank you for doing this. And if we are interested, we can indeed do that. We'd appreciate your feedback as well. Feel free to, I think NASPAA has its own feedback system, but also any feedback that you can provide to us, we would appreciate that as well. Anything that we can move forward in this direction that would help us.
Thank you so much, professors. It was really very helpful for as a beginner and to understand how this whole kind of machine learning really is evolving into the policy space and how useful it could be for the researchers and social, especially in our field, to use it. Thanks immensely.
Thank you, Christina or Michael. Any thoughts? So Melissa? If not, we appreciate your participation. I know we are coming at the top of the hour, so we really thank you for the participation. And if there are additional things, we can follow up on those.
Thank you so much. Thank you. Have a great day. Thanks.
And thank you, Stacy. You're a
Thank you.
Bye.
Good to see you all.
Bye-bye.